So, trying to boot the darn system. Let's try to record this area. Want to see what the heck is happening. Okay. So let's stop the video, see what the heck is happening here. So it's loading and then okay. P12BJ I7. there is still something ongoing here. Mm. So, oh, 'Let me see Twitter. Where is that? Twitter. X.com. Yeah. Uh, 1, 2, 3, 4, 5. Yes. Where is this? Okay. So now it gets stuck at I7. Does it show any other thing here? Let's see. Video playback at a really slow speed. This is stupid. Okay. I7. No, okay, and then it resets before reboot. On the same row. So this is some diagnostic codes that we are trying. Playback. Come on. Okay. I7. Here it is. Same rules, same color. Yeah. So this is looking at the book here, the basic kernel source secrets. So page 14. Mhm. But this is okay. Local. Yes. The PB, what is this? P12EJ appears on the top left, I7 on the top right. Both background green with white color. So this is the diagnostics. So the stack pointer, yes, this is the correct my voice, my god. The correct thing. Uh, all interrupts, and this is important. Why does it do this here? I don't want. Yes. Mm-hmm. The argument of the yes, yes. Yes, yes. One of the arguments of the bootstrap is the location where the kernel is bisected by its slew of yes. This is the yes. The location where is bisected. This address, while the third argument, yes, this is the third argument, must be obtained first since it is used to relocate the virtual addresses, which the yeah, that's correct. If the relevance base had as in factoring the sum, this is the whole, yeah. This would need to be considered. This is variant how they may be configured to break there are many megabytes of physical memory into ways. Yeah, for our purpose, the break is irrelevant since the kernel is and to a set of physical pages. Very much there is any it will be possible to run off the kernel physically discontinued if that if that were yeah leave it as an exercise to the reader to figure out what would be necessary in order to both the boot flags and boot. Oh, my voice is really bad. Both the boot flags and boot boot device are taken from stack. So actually, let's put this a different color because these are parameters. Boot flags, boot device taken from stack. And this is here. The boot flags is the how to end the device. The physical whatever is currently stored, the physical address where the contents are currently stored in here is computed by the relock subroutine. Yes. The relock subroutine, page 405, the port. Yeah. Low core, line 151. This is actually in which line is this? And this is line 151. So there is a slight mismatch. 150. Like 154. So the total number is probed for by the start of code NBPG. for address removal. Okay. What the heck is? Oh, is this guy trying to? I don't think this is a red thing. So it does this. This is okay. This part here is this one there. This thing here. This part is this one for ESP. EDX. Relocation, yeah. Pushes now. But wait, where is relocated? Line 405 of this one, yeah. Should be fine. Where's the reload? 405, yeah. Okay, that is an interesting thing. Here's the problem. The kernel is linked as a continuous. The link and complete. Oh, okay. Yes. That is absolutely true. This is a bug here. This is a problem here. This is absolutely true. The relock here. Note, what if relock is the upper is not in the lower. That can fail, right? We do a call, or is this BS? It should be a relative call. Call relative, yes. That thing crosses the hole. Yes. No, exactly. That will not happen. That will not happen. That will not happen. All call within artists are fine. No, so this is uh, mhm. That's okay. text. So the entire information, okay. What else could cause the crash? Let me think. No. Yes, and that, yes. When the kernel, and then it sets up page tables that were after paging is enabled at line 315. 315. For the page mode. Mm, the page, this is the T-kernel 005. And we don't see the number here, but we can see what is this? Oh, yeah. The floppy drive. Where is the floppy drive? Sorry for being switching here the windows a little bit, but I need to get to get things here. So this is the floppy drive view list, the T-kernel. Mhm. Still the same. Nothing changed. That's the problem. It's supposed to just halt. Well, it doesn't halt. It just reboots. Okay. Let's prepare a floppy for that. So this is where so take I take this floppy here. Test boot int 15. And I need the transfer disk, and I need the things here. Okay, this looks a little bit bad. This thing here, the transfer disk. Let's put the boot here. Let's try to reboot the machine. What am I trying to do? I'm trying to boot the machine. It's currently not booting in real hardware. It's booting in 86 box, but in my real hardware it's not booting, and I reconfigured here some things, and I was able to reproduce the bug in 86 box. At least I think I am. And now I'm definitely trying to see if the things boot again. So let me see. I have to put a, oops, not this one. Put the CD, put 386 is on FS. So let's see if the kernel boots. Yeah, that's what we said already before. None detected. Let's remount here's it, right? Come on. Yeah. And existing image, this one here. C is not there, so mm, rename a config sys. Ay, config sys to config alt. Rename auto exec add to auto exec alt. Reboot the machine and let's try. Um, so now I get this one here and put 6 So now let's see if it puts the thing. Mm. Okay. And it cannot mount root. This is what I see in the other system. That's good. So it's not mounting the damn file system here. No. So the parameter you're asking for is this one here, boot how to and boot device. It's the boot device that is passed here. So let's say in MS-DOS, this starts like this. The program, the bootstrapping thing. So let's try to let's try to explain this a little bit. I've been going on this already since quite some time. So we have a 386 BSD and an 8 out format, which has text instructions, data, BSS, and a configuration, which I currently am underlying here because I don't have this in my boot code, and that could eventually cause issues, but let's continue. And you see here the so the bootstrap, this bootstrap is actually can actually also be done if you're loading from the sector, from the boot sector, from the master boot record. Anyhow, the boot.exe, the program, so you have the CD-ROM that comes originally from Mr. Jolitz. You have here version 1.0. That's the one that is on archive.org. You have an install, but you have a boot.exe. You see here, boot.exe. This is a very small one. This boot.exe does what is described here. So the problem is I don't have the source code for boot.exe, so I'm trying to write my own. And for that, I need to understand what's happening here. And you have the kernel itself, you have data, and you have uninitialized things, and you have the configuration strings, which is something interesting I need to look. Now, the first thing to boot the system is to get the low core. So the assembly and primitives, entry and primitives, it's the low core where the start process is. Page 35. Sorry for my voice, it's really crackling down. Page 35. What does start expect? So the bootstrap, this is the bootstrap is what we're trying to do. We're trying to do a bootstrap. Yeah, it cannot access that. That's the thing. So the bootstrap so after this is done, you have the memory layout like this, and of course we have the 640 kilobytes, the IO memory, which is the VGA card and other stuff in the ISA bus and so on. And here starts the 1 megabyte memory. And the kernel start entry pointing is entering with the memory arrangement as set by the bootstrap mentioned above. So it needs to have it this is address 0. Then we have this is called the hole, a hole here. Let's write it, the hole, the memory hole. And it loads from 0 up to 500K, and if the kernel is bigger, then it continues from here to there, basically. And then when this is set up, you call start. And start will do a couple of things. And this is what's explaining here. So is page 35. Start is the machine-dependent program used to begin kernel operation. System initialization, interrupt handling. Start is a runtime start off of the kernel. Start, blah, blah, blah. So this is exactly what we want. So we want to pass control to start, but start expects something from the thing. So start expects bootstrap will load the kernel into memory starting at address 0. and successfully occupying space in physical memory. Since the IBM PC has its I/O bus memory or kernels larger than this, it will continue to go above the whole. That's what we saw here. That's exactly this thing here. So it starts with 0, goes until here, whole, then it continues to. Good. And now comes the point that you are asking. It will be up to start to then rejoin the whole. So it will then move the kernel in memory and put it into the memory position at once. The bootstrap passes 3 arguments: the boot flags, the boot device, and where the whole starts. So boot flags for number 1, number 2, number 3. And this is what needs to be done. Okay, and this is now happening already. So what you saw here, so what you saw in this thing here was already everything happening because those lines already come from the kernel. Okay, this already comes from starting the kernel. Let's do it again. So we reboot the things here, and you see that the boot.exe that I'm providing, that I'm developing, is already doing that. And now it's actually an interesting thing because it's a relatively well stable, because I will tell. Okay, so here we don't have drivers for the CD-ROM. This is just a basic MS-DOS, but here we have, I put some utilities here. One of them is the boot.exe, which I'm compiling. This is an MS-DOS machine here. This is what I'm doing. So you have the boot code here and you compile it there. Okay. So, and boot slash question mark. Upload output of the process somewhere I could read. It's a little bit difficult to do that because I need to do this so everything OCR, and it doesn't doesn't help so much because I'm going to tell you what's happening. So or let me actually show you some other thing. Let's stop this machine. Let's let me just see here. I will show you some other things here. So let's go, and you will see, you will understand a little bit better what I'm doing and why it doesn't make so much sense, the request that you're having. So this is the original CD-ROM that you can download from archive.org. There you don't find, or let me actually think where. Okay, you don't find that's the things, but you have a boot.exe here in the original CD-ROM. And what I'm going to do now is I'm going to do the following. I have a floppy drive that we can boot. So let's go here. And you see here, those are floppy drives. This I just took from an MS-DOS. You can create this floppy drive in anywhere. You can create a bootable floppy drive from MS-DOS anywhere. Install V1. So let me just mount this floppy here. You are going to understand already what I'm trying to do and try to show you. So just wait a little bit, just bear with me. So there is this boot here, and I'm going to delete these things here, and I'm going to delete my boot. The boot.exe, this you see, it's a little bit larger, so I'm going to delete, and I'm going to go to the original CD-ROM, I'm going to get the original kernel that came from 1994. I'm going to copy it there. And I'm going to get the boot.exe. I'm going to copy it there. Okay, so both of the things are there. And now let's, oops, okay. Let me unmount the things. FreeBSD boot, unmount, eject. Now, let's go to this thing. So I created a floppy. It's a bootable floppy from MS-DOS 5.0. Now, what I'm going to do is I'm going to change this machine. This is a test machine, and I'm going to go here, and I'm going to say this was what was originally there. I'm going to say that in the storage controllers, we have a SCSI and AHA 15, let's 154C, which by the way, I bought one, so I have one for my original machine. And I think IRQ, it's probably the 330. So let me check exactly where this goes. On the original CD-ROM, I want to do this in a separate video, but since you are asking me already, I want to do a tutorial afterwards. There is under user. Let's go through a command line, otherwise we don't get there. So there is this is the original CD-ROM. There is the user, source, kernel, and this is AS device. The AS has the Adaptec SCSI 330. Regardless of conflicts. Okay, so it has the 330 here. So let's go back to the machine and let's configure this with the 330. Okay, this looks good, I think. IRQ, I will leave it at IRQ 11. Let's see if it detects. And now, instead of having an ATA-P, I'm going to put a SCSI drive at 00. That's fine. Okay. Now, I'm going to put the original ISO, the 1.0, and I'm going to put, stop, I'm going to boot that floppy, image write protect, and install V1. So let's restart this. I'm not using OpenClock. That's too much stuff. Too much stuff on going there. Okay. Let's see if this loads fine. Of course, it didn't load. Okay, the CD-ROM is not loaded, the drive, so but this is okay. We have here in the directory, we have the commands, and I have boot, and I have, this is the original boot from that came from Mr. Jolitz. And then we say we want a drive. So we want the 386 BSD, which is currently in this disk. The boot device, let's say that this is going to be the Adaptec here. So AS2D, AS2D. That's right. So it tries to load the thing, the text. That's now the interesting part. Yeah, And now it goes the whole process. Panic cannot mount root. Why? AS port, okay, IRQ11, DRQ33011 load. So let's see if we have that one. The controllers, 11, MA6. Yeah. Why didn't it detect? I'm now a little bit confused. It should have detected. So basically what I want to show is that I can boot the system with an Adaptec 154C. And it's just a question of configuring this correctly. I'm a little bit confused that it's not going. Probably something related with the thing here. Maybe a little bit too advanced. Speed, it's a SCSI, yes. Let's see. Should be fine. And the machine, maybe this is something related with the machine. That's 386. There is definitely something going here that I didn't, I'm not accounting for. If I cannot get this to boot, I will try another configuration that I know that works. So let's see. So boot 386 PST AS 0P. That should be okay. Come on, you can do it. It's the, oh, it booted. There we go. See, it booted now. So attached this one here, and now look here. If I do ls/, what I see here is actually the CD-ROM. So the CD-ROM is mounted as the root device. So I can start to install. Okay, I can start to install. I don't want to do that. The point is that as a device here, this has mounted. It has mounted the CD-ROM as a SCSI. Now, what was not originally implemented in the kernel was booting from an ATAPI, from an IDE CD-ROM. And I've added that to the kernel. So that's why it doesn't make sense to send the things, because it's not a normal thing. I'm still debugging stuff. So this is well implemented, and you can go to archive.org and you can download and you can configure the machine as I have here, and you will be able to boot the things, no problem. But I don't want that. What I want is to go here, take out this guy, and I want to go here and I want to put an ATAPI device. That's what I want to do. And for this, the kernel does not support. There is no code for it. There is the beginning, so between version 1.0 and 2. Something, they were releasing, Mr. Jolit, sorry, was implementing some things. The ATAPI driver was not completed in the kernel. That's the thing, that I'm trying to complete the driver, and I completed it already, and the driver is booting on 86 box, but it's not booting on the real hardware. And this is where I stand now. I have the driver implemented in my code, in my repository, that I still not open for everyone. I have a repository that I'm going to open once things are solved. And in that repository, I've implemented the ATAP device and it boots on 86 box, but it doesn't boot on my machine there. Let's, do I have a thing here? Let me try to see. Not this one. Yes, on this machine here. I wanted to boot here on this CD-ROM here. And this is an this device here is an IDE drive, and I wanted to boot here. And it's not booting here, and it's currently not booting on 86 box. And that's where I stand now. Okay, I hope I can clear things out a little bit. Where is this capture string? Yeah. So, and for that, because the original boot from Mr. Jolitz does not support, so there are several components that are missing. One is the bootstrap, because if you have a device like this, I could do another thing. I could take the hard disk out and I could make an image, but I want a full installer. I really want a full installer for everyone to be able to reproduce this. So, and for that, I need to recreate the boot.exe, and I need to put the ATAP drive. And that's what you're seeing on the screen now. I hope it makes sense now. So it's a little bit difficult to explain. So, and this is the test boot here. This is the boot that I'm developing. So I restart the computer and it has some random crashes because of whatever. And the good thing is that I was able to reproduce parts of the crashes that I have in the hardware, in the physical thing. I'm able to reproduce here. For the stuff, I'm really using floppy drives. It gets probed. It gets probed, and you can see that the things are there. So this is what. So here, boot. This is the boot 386 BSD. As you can see, it has another argument. So root device WD1D. WD1D is the Western Digital device 1 because this is placed at 01. So it's a primary slave device. This was maybe wrong before. Let me try to see if this goes better like this with the 1.0. And it's an ISO file system. And those are the things, those are the flags that you need to pass here to the start. Okay, that the stuff that I was looking here, the how to boot and the boot device. Okay, so those are the things. And once you fire up this, which is now with my own boot system, this boot system will boot the previous 386 BSD kernel. If you want to see, I can show it to you also. The one that Mr. Jolitz is providing, so it should also boot it. Just in case, just to test it, because I was developing some things with the boot. I will try this bootloader with the previous one, with the ATA CD-ROM, just in case. So it's loading it slightly different. So now you see the probing. Now, now it says WD1 not configured. You see, and this is bad. Okay, that's an interesting thing. That's a really interesting thing because it said WD1 is not configured, and now it tries to mount the root, and it gets into panic. Cannot mount root. Okay, this is a good question. Let's try to revert back to this other controller. to this one here. So this is 330, I think, 11, 6. This is B. I want C. 331. Okay, this looks good. Let's actually put the SCSI. And let's try to reboot. And try to boot with my bootloader. And it should boot. I don't see the reason why it should not boot. So boot 386 EST, and it's device AS0D, and it's an ISO file system. So let's try. It was booting before. I did some changes. Now I did after these changes. Let's see if it boots, and I think it should boot. I don't see much problem. I don't see a big problem here, but it's good to think you can do it. The other thing is to show you can do it. There we go. WD1 not present, and there we go. Here lots of debug statements, automatic boot in progress. You can see the disk is blinking here somehow. This kernel has a little bit. I should be booting the original kernel, not this one. But as you can see here, it identified the disk. AS is attached, and maybe this is maybe a problem of the kernel. I made a mistake. I need to. This kernel might be tainted. Okay, and it's doing some bad things. Let's put actually the correct kernel. For that I need to recreate the floppy. So in that case, I'm going to mount this one here with the boot device. And let's go. Where do I have a terminal? Oh my god, so many windows. So I have the boot floppy, and here let's copy the original kernel to the boot floppy. Okay, you can see it's a little bit larger. My kernel is a little bit larger. Let's just copy this. Before copying, I did something bad. I hope that this is okay. I should have actually unmounted, ejected the floppy. Hopefully this is fine. Let me eject the floppy. Of course it cannot, because I need to get out from here. Doing too many mistakes. Now, let's attach the floppy again. And let's reboot the machine. It was about 500 kilobytes. Let's see that the kernel is correct. Okay. Here. It's the 38 XPST 500. Okay, so that's good. Boot 386 PST. Root device AS0D. It's mounted. ISO file system. So this is the original kernel with my boot loader. PC intern. I don't know if you can see the book, but and the book from Mr. Jollip is also here. Come on. Attached. That's it. Alas. I mean, my bootloader boots the kernel. That's it. Okay. So, um, uh, yeah, it just boots it. So you see here, AS attached here, and we're fine. But again, I don't want this. This is not what I want. This is not the droids that you're looking for. So what I'm looking for is none here. And I'm looking for hard disk floppy here, ATAPI there. Let's do this. And this is not available anywhere except in my machine because of the ATAPI driver. Yeah. This is booting already since a couple of weeks. So if I would have a bug now, I would be I would be in serious trouble. I'm working on this since it's already since a couple of weeks I'm doing this. So and I was able to boot the things. I'm sure if I have the hardware here, so I bought the Adaptec card for the SCSI thing, but I don't want to spend money on a CD-ROM for that. It's too much money. I already bought the machine and so on. No, so I definitely want to boot this with an ID drive. And the other thing is I don't want to do a copy of the hard disk. I could go here because I have the storage controller. I could just take this image and do a bit exact copy to the hard disk I have here, and 386 PST would be running there, no problem. I'm absolutely sure this could be done, but I don't want that. I want an installer. I really want my installer. It's the ATAPI driver that's causing the problem, but uh, I was suspicious that my bootloader was also causing problems because I was having weird crashes and random things, and I need to test now. I was been developing, further developing. I've been developing this bootloader already since quite some time, and even now I find some things here that I need to watch out for. For example, the original one probably supports these things here that I still don't support, which is this configuration here. I need to investigate that and implement this into the bootloader. Um, of course, I will be releasing when this is available. I will be releasing the code, all the code for these things. So the boot.c, for example, is here. And this stuff with Xcode. Yeah. And not only this, the installer, I have some installer and I have lots of stuff there. So all the code is currently here. And it has quite some additional functionalities. Okay, so yeah. uh, quite some additional stuff in. So put slash question mark. So there are some things related with configurations. Put slash h, I think. This is not MS-DOS style. Put that. Yes, exactly. Scan, for example, there is a scan here for looking for device configuration strings and so on. This is stuff that is not originally in the bootloader. Yeah, I will. What the heck is this? Here slash W. Oh, okay. Okay. So boot 386 PST. And what I generally do is I make a video because things go so fast. So I just go here and I start recording a video, and then I can scroll back. Root device WD1D, it's an ISO file system. So it passes these flags to the kernel. Now it's a question that the ATAPI drive is not doing the proper things. And for the time being, the interesting thing is, is it even detecting the CD-ROM now? Because before I think it was, and now I think it was not doing it, and there might be some interesting. I know that it's not detecting. Yes, I'm trying to. Not modern hardware, it's still old hardware. Okay, as you can see, it randomly crashed here, but this is my own. Yeah, it's my own kernel. This still has an. But here, this is a little bit weird. Okay, let's try to put the P. There was the 3.5. I can tell you one thing. In my 386 in my 386 machine, in the real hardware, this is really booting. It's really identifying the CD-ROM. So boot 386 W1D ISO X. Let's see. Again, panic. And it's not detecting the CD-ROM now. So I can actually stop recording now. That doesn't mean anything. What happened here? Because this was doing it before. Um, 01. Uh, so let me try and um, let me try with the real hardware if this is detecting this kernel. Uh, for that, where is my thing here? For that, I need. So sorry, I will put a little bit of privacy. So this is some old stuff, 386 ST. And this should actually, yes, because here I have the test kernel, the tkern.pin. This is the test kernel that I'm developing, but I will put the latest kernel there. And let's see. Okay, this is, I'm not going to do this thing for now. So let me take out the stuff here and let's go to this one here. Let's put the floppy as it should. So this is the floppy here. It has the G curve. Let's remove this one. And now in my Git project, there's the kernel. There should be this one here. The debug kernel. Now I copy it to the floppy drive. So let's try let's try to get that from here and so get the new floppy.